Here's a quick note on the notation that we're using for the equation of an ellipse. So there are sort of two general situations when you have an ellipse whose center is at the origin. You can either have your major axis horizontal, like this ellipse on the left, or your major axis vertical, like this ellipse on the right. When the major axis is horizontal, there's general agreement on how to name everything. Most sources write the equation like this: x squared over a squared plus y squared over b squared equals 1. And in this setup, that means that this right-hand vertex is at plus a on the x-axis, and this left-hand vertex is at minus a. B is the semi-minor axis, so this top point is at plus b on the y-axis, and this bottom point is at minus b. Because A is the semi-major axis, A has to be greater than B, and we ended up with this relationship between A, B, and the focal radius C. Remember, hiding in here somewhere is the focus. Well, there are two foci. The focal radius is this distance, and that's called C. And we have this right triangle like this, and the hypotenuse happens to be A units long. And so using the Pythagorean theorem gives us this relationship between A, B, and C. So this is pretty standard when your major axis is horizontal. There is some disagreement on how things should be named when the major axis is vertical. So there are two ways you could set it up. Either for this first option, you still use A for the semi-major axis. So this time the semi-major axis, the major axis is vertical, and so the semi-major axis is the y-coordinate of this top point. So that's A up here and minus A down here. And then your right-hand and left-hand points, those are on the semi-minor axis, those are on the minor axis, so that's B and minus B. And then you have your focus, your focal length, or your focal radius C with this right triangle sitting in here. Okay, and this is the option that our book uses. So in this case, the equation for the ellipse is x squared over b squared, b and not a, because b is the semi-minor axis, and that's in the x direction this time. So x squared over b squared plus y squared over a squared equals 1. A is still greater than B because A is the semi-major axis and B is the semi-minor axis. The major has to be longer than the minor. And you still have B squared plus C squared equals A squared. Some sources don't change where A and B are in the equation of the ellipse. So in this case, these right-hand and left-hand points would be A and minus A. The top and bottom points would be B and minus B still, just like in our other ellipse. And so the equation for the ellipse is still the same. But this time, rather than swapping the position of your letters, you just remember that if B is greater than A, then B is the semi-major axis and not A. So, so in this situation, you'd have B greater than A, and also the relationship between A, B, and C changes because which of A and B is playing the role of the semi-major axis has changed. So always it's the semi-major axis on the right-hand side of this relationship, no matter what you call it. So our book goes with the red option on top here, but I just wanted to warn you that some people always keep A and B in the same place, and just whichever one happens to be the larger one is the semi-major axis.